Walked away.
Didn't walk
Come
away.
back.
She's not gonna come back. All right. Here's some fun data. It's all the what? It's all the trees.
Oh, sorry. We're talking biology.
That's okay. Talk biology. I just thought of something up here.
No.
5 credits.
So, that's right, Davidson. But you got a class. So this is a little bit old. I haven't had a chance to update this yet. I've been getting caught up with other administrative stuff, but it doesn't matter. Just like it doesn't matter if it's 4 friends. The math behind the logic is going to work, and the pattern is preserved. So this was about 5 years ago. I decided to check some sale prices of Bend homes for sale at a given time. So what you're seeing is a frequency distribution, number of homes listed within certain price cutoffs. So between, I think this was $50,000 and $100,000, there was about, looks like about 10, maybe 15. Between $100,000 and $150,000, looks like about 120-ish, maybe 110. So you can see the price cutoffs, what I did, it's in thousands of dollars, or hundreds of dollars, excuse me. Hundreds of thousands of dollars. So 1 is 100,000, 2 is 200,000, and so forth and so on. So, and so forth. And what I did was I took out the outliers. Now, I've used that term a couple times. Have you heard that term before I was using it, the word outlier? When I say outlier, what do you think of? Extremes. Data that's
just too far out from the...
Good, Alicia. Data that's too far out to be considered
really a part of the
data set. Very good. I love that definition. I love that. So, data that's too extreme to be considered part of the same data set. Extremes? Extremes, love that. Anything else? So in other words, atypical, yeah? Something's different about that data. Okay, now what I find so interesting about this data set is, this is what you're looking at right here, has the mathematically calculated outliers removed. Which means, see that $800,000 mark out there? There were homes way past that. 14 million, 18 million, 22 million. Those were considered unusual, but 800,000 wasn't. That's what blows me away about the calculation of the outliers that I did. See, $800,000 for a house, to me, it kind of makes my stomach turn. Just a little bit. And when I say a little bit, I mean a lot. Right? So, but mathematically, this was considered the normal chunk of data, mathematically, without the outliers. Okay? Which is kind of crazy. So that graph technically kept going well into the humanities offices. Well into the humanities offices. I mean, it was crazy. Some of those extreme, very, very atypical data points were way out there. I took them out, but just to focus on this one, to on one screen. Grab a measure of center and tell me what it is based on this graph. Mean, median, or mode. It's up to you guys. It's up to you guys. Think about this. Let me see hands on this one, because now the data has changed. It's changed a little bit. So you guys pick. You guys pick. Stacy?
Sandy.
Sandy!
She's close.
Close. Sandy. 4 for what?
The median.
Median is 4. We're going from median to 4. Okay. Right there? Okay, median's 4. Good. Anybody else?
3.
Davidson?
I'd say median of 3.
Median of 3. So we've got kind of a range of values about this, around this 3.5. So it's 5. So actually, can we go, let's go easiest to hardest. What's the easiest one to find? Tell me your name.
Linda.
Touche, my friend. Linda. Excellent. That was so awesome. Linda, go.
What was I gonna...
I don't know. Don't tell me your name. Don't tell me your name, because now you're Linda. Go for the mode, I'm guessing, yes? What would the mode be?
It's like 1.5.
Right. So let's call it 1.75, right? It's going to be this guy right here, because he's the highest bar. Mode's going to be the most obvious choice. Most obvious choice. Thank you, Linda. Which one's the next easiest to calculate? Median. I'm thinking, I tend to default to the mean or median is almost equally difficult. Let's go with median. We've got to do some crisscrossing, right? So Sandy, when you did the 3, Davidson did the 3 and Sandy did the 4, I think you're both pretty close. If you add up all of these extreme, I call these extreme, they're not really outliers, but they're still the highest values. Bop, 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 bop. Those last 4 are going to cancel this one and a big chunk of this. If I cut a little more off, like this one and this one, I'm probably going to lose all of this. If I cancel these and this together, that probably cancels this, I'm guessing. Is this fair? I mean, we can do it more precisely, obviously, with with care and caution. But ballparking, we're going to get somewhere in here with the median, yeah? Good. So the median's going to be somewhere in that neighborhood. I've got the actual data here in a second. We're going to pull it up on the screen. How about the average? Not as easy, right? Not as good. What Joanne's doing is she's trying to balance, and what David's is doing, they're balancing, right? You guys tell me where to stop.
Now.
Okay, first vote for here. No, he's joking. No. No.
Here.
There? I'm going to keep going. You guys keep telling me to stop. There.
Stop.
Okay, keep going. Stop. Okay, so it sounds like most of you were in here. Here's the actual calculated values. I think. Yes. Those are the actual calculated values. The average is almost exactly $300,000. I'm going to pull this back for a second. Oh, crud, they came out at the same time. Sorry. There. The average is almost exactly $300,000, so it basically sits right about there. Right? Which is damn close to where you guys said it was, wasn't it? The median sits at 275, which is actually a little bit further south than we were thinking. But again, it's hard to do that ballpark when the data looks like this. The mode, you guys nailed it, 175. Now, look at those numbers. And then look at the numbers to the right, which are the ones I calculated by using all those excessive extreme ones that I took out for this data set. How do they compare?
Almost the same.
So this is just this. This is when this and all the other tail ends that I had cut off originally.
The average. Was
Riley, go, my friend. The average jumped up by $100,000. Now, why would that have to happen? Joanne, go.
The outliers.
Yeah, why would the average move that way?
Because they're higher.
They're higher.
So the extreme, they're calculating the extreme.
Right, the average is going to move to the outliers. Think about it like a tray of cookies. And this sounds ridiculous, but your hand is here balancing this tray. Somebody has just come in and dropped a bunch of cookies where? Where does your hand have to go if you want to balance it? It's going to have to move out that way to balance those cookies. Now, to know exactly how far it has to go, you have to know exactly where those outliers are. More on that to come. But get this idea down right now. The average chases the outliers. Now, if we added the same number of outliers on this side, the average might stay directly in the center. Maybe. Now, we can't because you can't go below $0. Unless you're paying somebody to take your house away. That makes a lot of sense, right? But think about that. Just keep that idea. Joanne, you nailed it. Davidson, you nailed it. Outliers pull the average towards the outliers. How much? We'll get to that. We're metricing that soon. I always say that, Tara, don't I? We'll get to that. We'll get to that. We are getting to that. It's getting there. It's on the list of things we're getting to. I thought of you in 244 yesterday with the sample size calculation. It's like, ah, Tara was over here. How about, let's skip the trim mean for, now you know what the hell, let's talk about the trimmed mean. What the trimmed mean is it's often used, has anybody heard of this before? The trimmed mean? So it's got a 5% trim, 5% trimmed mean. What that means is take the 5% of the lowest values, throw them out, and take the 5% of the highest values and throw them out, and then re-average what's left. Why would you do that? Even in what way? Oh, Addison, go ahead. Addison? Good. In what way even? I like that.
You trim off the unnecessary stuff and make it even towards the middle.
Good. We're trying to find, I love how you said towards the middle. Well, we're trying to find the measures of the center of a data set. We're trying to find one number or a couple numbers that illustrate where the typical values are. So Addison said unnecessary, which I love. Get rid of the super, super inexpensive ones and the super, super expensive ones because they're not typical. Toss them out, re-average the middle. And look what happened when we did that. The average dropped $50,000. That means we lost more of the more expensive houses and the least expensive houses, which makes perfect sense. We would have lost these guys and some of those out there in that tail. So it's still above what it was without outliers, but it's much less than it was when we included all the data points, including ridiculous. Good! How'd the median change? How'd the mode change? They didn't. They didn't. Why didn't they?
The median is not for everybody.
Say that again, right? Go with the median. Go with the median.
The median counts for everything, so if you only have a few things, it's not really going to change much.
So the median being 275, that means it lives in this bar right here. In order for us to get knocked out of that bar, we'd have to have a whole buttload of data points over there. Because each one of those highs has to cross off one of these lows. Go ahead, Trinity.
I thought we did though.
You thought we...
Are you talking about all the data that you didn't include?
That's what I'm saying. If we included all those outliers and if we don't, the median doesn't change. That means there must have been so few of those super expensive houses that even though we chop them off, it doesn't make the median move any further this way. Yeah, now sometimes it will shift a little bit depending on whereabouts in that bar it is, but it's not going to make a mad change of position. Why didn't the mode change?
Same reason.
Same reason, right? The only way the mode, because it's the most, so Riley, the only way the mode could have changed is if what happened?
There was a whole shit ton of them.
Good, I like that. Metric shit ton. If there was a huge bar somewhere down here, but if there was a huge bar down there, could we rightfully call them outliers?
No.
If there's a huge bunch of them, it kind of goes against the unusualness. Right? So then we'd have to be like, what do we talk about this? Don't worry, we'll talk about that next. Because you do have to talk about that. Sometimes that happens. Literally next, Darren. But first, I want to make sure you guys understand how to discuss this data. I don't think anybody in this room is going to call that a bell shape. Because it's not a bell shape, it's a squashed bell. It's like it started as a bell and somebody leaned on this side and shifted it this way. I call that skewed. Statisticians also call that skewed. Sometimes they call it skewed left or skewed right. I don't like those. If you had to say which skew that was, what would you say? Skewed. Who says skewed left? Who says skewed right? The technical definition is skewed right.
Why?
Good, good. I asked statisticians why, and I was told by a statistician, I said, oh, it's because the average moves to the right because of the tail, because of the outliers on the tail. The average is going to move to the right. And I said, how do you explain that to your students? Because when I look at that, it looks like it skews left. And they say, oh, we just tell our students, just think about what you think it should be and do the opposite. Oh! So you know what you're going to call it? You're going to call it skewed data.
Well,
You're going to call it skewed. Go, Faith.
I'd say it skews to the right because if it wasn't for so far out to the right, it could be a bell curve.
Sure.
So because it has to go so far
Hey,
out to the
I love that. I love that. But the thing is, see how that started with a conditional if?
Yeah.
That's the trick. I like definitions that aren't conditioned. I like them to apply for all cases. So if it leans, it's skewed. I mean, that's okay. That's an okay if. I don't want a double if. If it leans and if it doesn't go so far, then we're getting these crazy nested kind of definitions. I love what you're saying. There's also ways to measure skew. How far away from a bell curve does it have to be until you call it skewed? Because you think about it, if you think about it, I'm going to back up for 1 second and then come back to this, so don't get upset if you're right. And you have this PowerPoint. You'll have this PowerPoint. That's technically skewed. That's not a perfect bell. That's not a perfect bell curve.
Would you call that
But
skewed to the left?
I would call that a bell curve because it's so close to a bell curve. This shows more aggressive skew than the other one. Yes. So the question is, how skewed is too skewed? That's a question we're going to answer in this class. Taryn, stop listening to me. I just did it again. We need more tools to measure the skew. We're developing those tools now. We've got 2 of them. We need one more. And Bert and Ernie will help us with that later today. So I avoid the average on skewed data. I actually called somebody out. It was about 2009, maybe 2010. I found a real estate agent in town using averages instead of medians, talking about house prices for house sales. I sent him an email. I'm like, dude, why are you doing this? Like, you're giving an inflated view. He's like, I know. I want to give the community hope. Because he knew by using, I was pretty impressed with this actually. He knew by using the average, he was giving a number that was higher than indicative by the median, but he wanted the community to feel like things were recovering. And I'm like, dude, I can't fault you on that. It's like, that's totally cool. Totally awesome. Totally wrong, but totally awesome. So you get a hall pass. Because in spirit, your heart's in the right place. But it can be a bit misleading. It can be a bit, I'm more on that momentarily. I've got some funny examples from my anecdotal collections of history that showed us. What do you think of Alicia right now? What do you think
Well,
of?
I was just thinking that could also be applied to our economy as a whole.
Sure could.
Like, there's that false sense that the economy is getting better, but
Yeah, depends on how you define better, right?
yeah.
It depends on what your metric is
Not as bad.
and where the, or not as bad, right? Not as bad means better, right? It's still crap, but it's not total crap. No, that's very, very good point. Yeah, medians are generally a pretty safe bet. It's just that a lot of statistics doesn't apply to medians, but we're getting into that too. All right, here, I told you I was going to get to this, Taryn. Here we are right now. Here's some of my own class's data from, I think this is about 4 or 5 years ago. It was the last time I taught Math 95, which it's been a long time since I taught Math 95. I gave an exam to 63 total Math 95 students that term. Their average grade was a 71. The median grade was a 78. The minimum grade was no lower than 50. The maximum grade was no higher than 100. I want you guys to draw a histogram based off of that chart. Just fill the bars in with what you think it looks like. I know I'm not giving you much to work off of. I want you to draw a curve of the day. Remember how we just looked at LDL levels? We just looked at Bend house prices? I want you to draw a similar histogram with 5 bars. How many were in the 50 through 60? How many in the 60 through 70? How many 70 through 80? How many 80 through 90? How many 90 through 100?
You didn't give us enough data.
I did, you're right. Draw what you think it looks like. You can't draw it exactly without having the data, right?
There's not enough data.
Well, I told you the average was 71. You can start with that. The median 78, and there are 63 students. I know I didn't do it's incomplete. Draw what you think it would look like. Jesus, no. Poo. Everybody except Riley, draw what you think it looks like. Goodness. We're gonna do long just fine.